So lines A and B have different y-intercepts. When line A is reflected around the y-axis, so remember this is the x-axis and this is the y-axis here, when it's reflected around the y-axis, so it goes from being, I don't know, we'll call it like this. When it's reflected around the y-axis, it becomes like this. Is its reflection parallel? Is its reflection parallel to line B, which we would just say is like that, and pretend like we don't know whether it's parallel or not, because we don't. So the key here is knowing that when you reflect something along the y-axis, you give it a negative slope. Whatever the line was before, it's now a negative of that. So we basically need to figure out whether the one line has a negative slope compared to whether line B, we'll call that B, has a negative slope of line A. In which case, then they could be parallel. So, and it has to be the negative, not just a negative slope, but a negative of the slope of the other line. Okay, so statement 1 tells us that line A is perpendicular to line B. So when they start out, you know, one is like this, and the other one is like this. The only way that when a line is perpendicular, that means that their slopes, so perpendicular, I have to spell it right, perpendicular equals reciprocal slopes, not negative slopes. And so the only way that a perpendicular line could also be reflected along the y-axis and have a reciprocal slope is if they have a slope of 1. You know, so if they are exactly, you know, y equals x, you know, a slope of 1, or you know, y equals x plus 3. It doesn't matter what the y-intercept is, but if they have a slope of 1, if you take a perpendicular line and reflect it over the y-axis, then the lines will be parallel. If they do not have a slope of 1, then they are not going to be parallel. So statement 1 is insufficient. It depends on whether the slope is 1. That's what our answer hinges on. So A is not sufficient, nor is D. I don't know why I put insufficient there. We just cross them off. Anyway, statement 2, the slope of line of B is greater than 0. That's nice, but we don't even have line A, so there's no way that that would be sufficient. We get rid of B. In conjunction, the slope of line B being greater than 0 and line A being perpendicular to line B still doesn't rule out this idea of the slope being 1, because 1 is greater than 0. So if the slope is 1, then they will be parallel. If the slope is not 1, then they won't be. So even in conjunction, the two statements are insufficient, and the answer is choice E.